Okay, we are discussing about the metal casting process. Last class we discussed about the sand casting process. Today's lecture we are going to discuss about the other casting processes: die casting, permanent mold casting, investment casting, centrifugal casting, and continuous casting process in detail. Okay, let's move to the today's lecture. First, we are going to discuss today the die casting operation. Die casting operation. Die casting operation. What is meant by the die casting? This casting method is used to manufacture item in bulk wise. Okay, this process is used in mass production. Okay, mass production. If item has to manufacture in a bulk wise, okay, bulk wise, this die casting operation is used. Okay, then in die casting process, production rate is very high. Steel mold is used. Okay, steel mold is used. Okay, steel alloy mold is used. Then the molten metal inject into this steel mold with a greater pressure. With a greater pressure. Then molten metal inject with high pressure. Okay, with the higher pressure. So then what happened in this process? In sand casting what happened? In sand casting we are pouring molten metal to a sprue. Then the molten from the sprue, this molten metal flow to the cavity area, product cavity area, due to the gravity. Okay. In a sand casting, what happened? Sand casting, what happened? We are pouring molten metal to this sprue. Okay. We are pouring molten metal to this sprue. Then what happened? This because of the gravity force, this molten metal flow to this cavity chamber. Okay, due to the gravity pressure. But in die casting what happened? This molten metal inject into the cavity with a greater pressure, applying using the hydraulic cylinders. Okay. Then this process the mold make using the steel, so that the mold making cost is very high, so that this method only suitable for mass production of items. Okay. Then this process, there's a two type of process. The two type of process called the hot chamber die casting and the cool chamber die casting processes. First one, cool chamber die casting process and hot chamber die casting process. Hot chamber die casting process. Okay. Here the die is mean the mold. It is made using the steel alloy. Normally this die casting process, the low melting temperature metals are casted. Okay, normally the low melting temperature metals, that mean non-ferrous metals like aluminium alloy, copper alloy, and lead, tin, like low melting temperature metals are casted using this die casting process. The production rate is very high. Let me explain the process in detail. Then let's look at this cool chamber die casting. Let's take the cool chamber die casting process. Okay, first one, cool chamber die casting process. This operation done on the machine. Okay, let's take the first one, the cool chamber die casting process. In cool chamber die casting process what happened? Okay, let me draw the mold. This is the mold. Okay, let's take this is the product cavity area. two halves of mold. This is the movable half. This is called the movable half of the mold. This is the stationary or fixed part of the mold. Okay, and this is the short chamber. Okay, short chamber. Then this is inside is a barrel. Okay, and we have the motor metal pouring at here. Okay. Then the hydraulic flanger. This is the flanger. This connected to the hydraulic cylinder, hydraulic jack. Okay. This is the typical structure of the cool chamber die casting machine. Then this die open and close process is also done using the hydraulic jack cylinder. Okay. Then the motor metal poured to this cavity using the ladle. Okay. Then what happened? Motor metal poured to this cavity. Okay. Then once the short chamber fills with the motor metal. Okay. Then this one is this part is called the movable half of the mold. Movable half of the mold. Okay, movable half of the mold. Movable die half. Then this is the fixed die half. Fixed die half. The hydraulic toggle mechanism is used. I simplified diagram drew in here. But hydraulic toggle mechanism is used. But that is a simplified diagram shown in here. It means toggle mechanism is used in here. But I drew the simplified diagram. And this is the hydraulic cylinder. So then what happened? Here also water cool channels also there. Okay, water cool channels there. Okay. Water cool channels are there. Cooling water channels. So then what happened after this motor metal poured to this short chamber? Okay, the mold close. That means this cylinder is activated. Then the mold is closed. Mold is closed. Then this cylinder is activated. This cylinder is activated. Then what happens? This flange extend. This flange extend. With extension of the flange, what happens? The internal short chamber, short capacity of the motor metal, the force into this mold cavity area. Force into this mold cavity area. So then what happens? The inside this mold, it solidifies because the water cool channels are there to accelerate the solidification process. Okay. So then this is the mold close position. Mold close position. Inside this the molten metal injected to the mold cavity, solidify inside the mold. It is accelerated by flowing the water through this water-cooled channel. The solidification process is accelerated. So then what happens after the part completely solidify? Then again this cylinder, hydraulic cylinder is activated. Then the cylinder is backward. So then the mold is open. Then this part can take out from the solidified part can take out from the mold. Solidified part can take out from the mold. This is the solidified part. The robot arm are used to take out the part in a mass production. Robot arm is take out this part from the mold. Then again the next cycle, the molten metal, this molten metal manually have to pour to this chamber. Then the molten metal next for the next cycle, the molten metal have to pour to this chamber. Then again the mold close. Then the plant is activated. The cylinder is activated. Then molten metal inject into this cavity with a greater pressure. This is a cyclic process. Then this cyclic process actually having the greater production rate, because the solidification time also can we can control the minimize by applying the water cooled channels. Okay. Then actually it having the greater production rate. Then if mold, by using the mold with the multiple cavities, again the production rate can further increase. Okay, if we can use the mold with the multiple cavities, the production rate also can further increase. Okay, then what happened in sand casting? We are molten metal flow due to the gravity pressure, but in here it is very high pressure is applied to this molten metal to flow into the mold cavity. So then it can reach, this molten metal can reach even in narrow areas of the mold. Okay, even to narrow areas of the mold, and also it can reach us to the very complex, narrow, thin areas of the mold. Okay, that is very important. So this in this process it can generate very complex geometries with greater finish. The dimensional accuracy is very high, and also surface finish also very high in this process. Dimensional accuracy is very high, surface finish is very high, and also the finish of the product is very high. That is the main advantage in die casting process. Production rate is very high, and also the surface finish is very high, dimensional accuracy is very high, and also the finish of the product is very high. But this process suitable only for mass production, item wise production. This process is not suitable. Okay, if the product is manufactured in the bulk wise, only this die casting process is suitable, because this setup, this is done on a machine. Okay, this is a simplified diagram I have drew in here, but it has a lot of component, a temperature control system, and also the hydraulic control system, and also the cooling system control, and also the robot arm to take out the part, solidified part. There's a lot of other component. This is done on machine, the fully automated machines. So then initial cost is very high. And also certain product capital cost also very high, because the mold making cost is very high, because this is a very hard die steel is used to manufacture this mold. For certain to cast a certain object, we have to make this mold first. Okay, the mold making cost is very high, because the machining this the mold have to machine using the specific type of machines. Normally the CNC type machines have to use to create this mold. So the mold making cost is very high. This material also very expensive. So this is only suitable for the mass production of item. Okay, this is called die casting process. So then let me explain this hot chamber die casting process also. Actually this is in here the cool chamber die casting process. This volume tracking chamber in a normal room temperature, but the hot chamber die casting process, this volume tracking chamber dip inside the mortar metal pool. There is a difference in hot chamber and the cool chamber die casting process. That means this chamber in a room temperature in cool chamber die casting, but in hot chamber die casting it is dip in a mortar metal pool. But in a cool chamber die casting process, every cycle this mortar metal have to manually go into the chamber. Okay, predefined amount of mortar metal, predefined amount of volume of mortar metal have to go into this chamber in each cycle in production. But in hot chamber die casting is a fully automatic process. It's a fully automatic process. Let me explain the cool hot chamber die casting process also. It's a fully automatic process. Okay. Hot chamber die casting process. In the hot chamber die casting process, only it's set up. That means this part is same. This part is same. That means it having the mold and the hydraulic mechanism is used to open and close the mold. This part is same. It also having the fixed half of the mold die and also the movable half of the die. Then okay, this part is common for this hot chamber die casting process also. The hydraulic cylinder, the ram type or toggle mechanism is used. Mostly the toggle mechanism is used. I have drew in a simplified diagram. Then this is connected to the flange. That means the volume tracking chamber, something like this. It's a cylinder. Okay. Then this is the it is activated using the hydraulic flange, and it is connected to the hydraulic cylinder. Hydraulic cylinder, this is the flange, and this is the outlet of the from the cylinder. Then there's a gating system. There's a gating system. The valve, the gating system. Okay. Then this is a dip in a mortar metal pool. This is dip in a mortar metal pool. Okay, this is dip in a mortar metal pool. Let me draw here. This is dip in a mortar metal pool. This is the crucible. Then it's a continuously heating. It's a close. Again the refractory wall. Then this is the burning fuel. This that means the flame or whatever is the heating hot air or flame is applied at the bottom. Okay. Then this is the mortar metal. This is the mortar metal. Okay. This is the mortar metal fills with this fills on this mortar metal pool. Okay. Okay. Then what happened? Then this is connected through the gooseneck. That's called the sorry. Yeah. this kind of a channel, it is called yeah. Then you can see this volume tracking chamber and the mold is connected using this kind of channel. This is called the gooseneck. Actually, the gooseneck mean it's a like a neck of a goose. That's why it's called the gooseneck. Is the fixed mold half, fixed die half, fixed die half. This is the movable die half. Okay, this is the hydraulic cylinder. This is the chamber. Where the molded metal trapped, certain volume of molded metal trapped by this chamber. Then this I'll explain this one. Then this is the flame. This is the fuel. Okay. Let me explain this one. Then what happened? When this flange move upwards, when the flange move upwards from the bottom, what happened? This gate is open. Actually, this is a gate. The gate is open. This gate is open. What happened? The outer molded metal, because of the vacuum form, this outer molded metal flow into this chamber. Okay, flow into this chamber. Okay. Then what happened? Okay, flow into this chamber. Then this chamber fills with the motor metal. So then what happened? When this flange, when cylinder is activated and when cylinder extract, this flange apply the pressure on this motor metal volume. So this motor metal forced to flow under greater pressure inside to this mold cavity. Inside to this mold cavity, when this mold in that situation the mold is closed. Okay, mold is closed. Okay, mold is closed. The same as in previous, there's a water cool channels also there. So then the bypassing the cooling water, the solidification process is accelerated. So then what happened? The mold is open. After it solidifies, then part can take out. Again, what happened? The mold, this flange move upwards. Then flange move upwards. Then the volume also, certain volume moves into this chamber. Then again the motor metal inject. Okay. Then this is a cyclic process. This is cyclic process. The two gating system also used. This is the one of the method. In another simplified method, this one is open somewhere in top. Okay, this one is open in somewhere in top. When the flange get move upward beyond this gate, this open gate, then the motor metal, outside motor metal can move into the chamber also. That is another gating system. So anyhow, the trap volume, this is called the volume trapping chamber. The trap volume, the force to flow into this mold cavity with the greater pressure using this hydraulic flange, hydraulic cylinder. Then this is called the hot chamber die casting process. You can see in a previous case, in each cycle, in a previous cool chamber die casting process, in each cycle this motor metal have to pour using this ladle to the short chamber. But in this situation, there's no, the process is fully automatic. Process is fully automatic. The volume tracking chamber dip inside the motor metal pool. This is called the motor metal pool. It is deep inside the motor metal pool. So then the process is fully automatic. Process is fully automatic, but the compared to the hot chamber and cool chamber die casting machines, the hot chamber die casting machines are very expensive because this setup is very expensive. Then again, the hot chamber die casting process. Again, I think you all got the more clear idea about the die casting process. Okay, die casting process. Then next we are going to discuss about the permanent mold casting process. Okay, permanent mold casting process. Next casting process we are going to discuss permanent mold casting process. Okay. Next casting operation we are going to discuss is the permanent mold casting process. Okay. Permanent mold means it use the permanent mold same as in die casting process. Same as in die casting process. Let me draw the mold. That means the steel mold is used. Same as in previous operation, the steel mold is used. This operation also is suitable to manufacture items in bulk wise. Okay, item in bulk wise. Okay, item in bulk wise. This is the two halves of the mold. Let's take this part you have to manufacture. This is the mold. Okay, this is the mold. Then water cooled channels also there, same as in die casting process. Water cooled channels also there. Then there's no injecting mechanism. In a permanent mold casting, there's no molten metal injecting mechanism. The molten metal flow due to the gravity. Okay, the molten metal flow due to the gravity. Then the molten metal pour to this mold. Then manually using the ladle. Then this molten metal flow inside the cavity due to the gravity pressure. The gravity pressure developed by this height of the screw. Okay, this is the molten metal feeds the. Then only the simple mechanisms are used to clamp this mold. They're mostly the simple mechanism. Some situations the hydraulic cylinders are used. In most of the situations, screw clamping method are used in small industries. This means this kind of hand wheel. This is a screw. This is the nut. Okay, it is screw. Then the screw. This is fixed position. Okay, so then this mold is clamped using this screw. Okay, then two halves of the mold the clamp using the screw. Okay, this kind of the screw mechanism. That means then after clamp this two halves of the mold metal can pour into this cavity area. Then the water cooled channels are activated. Then it accelerates the solidification of the molten metal. Then this clamp is released. Then the mold can open. The mold can open. Then the solidified part can take out from the mold. Then the mold is open. Then the mold is open. The solidified part can take out from the mold. Okay, after opening this mold, the solidified part can take out. This is the part. This is the solidified part. You can take out after it solidified. This is called permanent mold casting. It also uses the steel die, but there's no molten metal injecting mechanism. Molten metal flow due to the gravity, same as in sand casting process. Okay, then this is also suitable for mass production. That means when item in a mass production, the production rate is very high, but is less than die casting. The production rate is high, and also the surface finish also very high, surface finish also very high, and also dimensional accuracy also very high, but less than the die casting process. Because the die casting process, what happen, the molten metal flow with a greater pressure, then it can reach to small narrow areas also, but in here it is molten metal flow due to the gravity. So this simpler kind of object, that means the very complex geometry it cannot generate using this permanent mold compared to the die casting, because small thin layers, the molten metal cannot reach small thin layers like die casting process, because the molten metal flow due to gravity pressure, not the external applied hydraulic pressure. Okay, then this permanent mold casting and also in die casting process, in each cycle, in both the process, in die casting and also the permanent mold casting, die coating is applied. Okay, not each cycle, the die coating is applied, the ceramic die coating is applied in a okay, in a die casting process, the permanent mold or die casting process, the in each cycle graphite spray is applied to this mold. Okay, there's a this kind of spray nozzle, then this is a graphite spray as the high temperature lubricant. The graphite I use for high temperature lubricants. So then the graphite spray is applied. It enhances the fluidity of the molten metal throughout the mold. It enhances the fluidity of the molten metal throughout the mold, and also it enhances the release of this part easily after it solidify, and also it act as a certain insulation to thermal insulation. It avoid the immediate solidification during the pouring. Okay, these are that is why these graphite lubricants are applied. This is called the permanent mold casting. Compared to the die casting, is very simpler. Only the cost is the mold. Only cost is for mold. It also can generate higher surface finish and the dimensional accuracy, and also the production rate also very high compared to the sand casting, but less than the die casting process. Okay, this is called permanent mold casting operation. Okay, then next we are going to discuss about the next casting operation. That is also very important casting process, investment casting process. Okay, investment casting. Okay, next casting process we are going to discuss is the investment casting process. This investment casting process, again that is also suitable for mass production of item. That is also suitable for mass production of item. Okay, mass production. The dimensional accuracy and the surface finish is very high, excellent in this investment casting process. Okay, then in investment casting, suitable for mass production, and also the dimensional accuracy and the surface finish excellent. Then in this investment casting, mold make use in the ceramic refractory material. Then the pattern used to create this mold is wax. Okay, wax patterns are used. Okay, keep remember, mold make use in the ceramic refractory material. Then to create this mold, wax patterns are used. Okay, in this investment casting, mold make using the refractory ceramic material. N patterns are made using the wax. Okay, wax patterns I use. Okay, let me explain this process. It taking the it having the several steps. Let me explain it using some example. Okay, example. These steps I will explain in stepwise. Let's take this is the product. I will take very simple product, spherical shape we want to manufacture, because I can easily draw this spherical shape. That's why I took this spherical product we want to manufacture. Okay, product, as the final product we want this kind of spherical shape. Then the first step. What is the first step? This is the product we want. By giving the dimensional accuracy, we want to make the pattern first. Okay, that means we want to make wax pattern. Okay, manufacturing of okay, we want this is the product. By giving the dimensional accuracy, shrinkage allowances and other allowances, wax pattern we need. Okay, wax pattern. Then in this wax pattern, to make this wax pattern, we need wax injection molding process is used to make the wax pattern. Wax injection molding process is used to make the wax pattern. So that to make the patterns, we need the steel or metal mold. Okay, so that we are studying with the mold making for patterns. Okay, manufacturing of mold to make the patterns. Okay, manufacturing of mold to make the patterns. That means we need this kind of metal mold, aluminium or something. We need this kind of mold. This wax pattern also having this kind of connecting element also. That means this kind of thing. Then this is the mold to make the wax pattern. Okay. Then this is done. This cavity have to machine on this steel die house. Using the CNC machine operations I used to manufacture this die cavities. So then this is the first step, manufacturing of mold to make the pattern. This is manufactured using this some metal, aluminium or steel. Then this is the mold to manufacture these patterns. So then next step 2, wax injection molding. Wax injection molding process. Then this is connected to the injection molding. It's a specific type of injection molding machine, similar to the plastic injection molding process. Then this is the mold. This is connected to the wax injection molding process machine. Okay, then this is connected to the injection molding machine. Okay, I'm not going to draw the injection molding machine. So what happen in injection molding machine, this wax material, the molten wax are inject into this cavity, the greater pressure. Actually like in die casting operation, this wax is injected into this cavity, then this cavity fills with the wax, then you will allow to solidify, then the part can pattern part can take out. This is step 2. Then after wax injection molding, this is the part we are having. This is the part we are having. This kind of a pattern we are having. This is the pattern we are having. This is the shape we want. Then the additional part is there to connect into a wax sprue. This is the part. This is the wax pattern. The final wax pattern. Okay, wax pattern. This is called wax pattern is manufactured using the wax injection molding process. Okay, then next step, step 3. Next step. Then this manufacturing of wax sprue. The wax sprue also manufactured using this kind of wax injection molding process, but that is not specific to the product. That is a common mold is used to in every process to manufacture this wax sprue. That means this wax patterns, step 3, these wax patterns are assembled into the wax sprue. This kind of sprue, wax sprue is used. This wax sprue is manufactured same as in wax injection molding or wax casting process. So then these patterns, okay, this is wax sprue, wax sprue, wax sprue. These patterns are assembled. These patterns are assembled to wax sprue like this. Okay, so it is it's a 3-dimensional, but I have drawn a 2-dimensional view. In this elevation also the pattern can assemble. Then you can see the wax sprue. Then the patterns are assembled. I will write this step. Wax patterns are assembled to wax, that is also called wax sprue, wax and also called wax pattern tree. Okay, that is also called wax pattern tree or wax sprue. Okay, this is step 3. Then this is the complete pattern. We have completed the pattern. This is the pattern we use in investment casting process. The next step is very important. Then the next step, in step 4, this wax pattern dip in a ceramic slurry. Dip in a ceramic slurry. Okay, ceramic step 4. Then this wax pattern dip in a ceramic slurry. Ceramic slurry mixture. Okay, then this wax sprue is inverted. Okay, then the wax sprue is inverted. Then this is dip in a ceramic slurry like this. Okay, this is the wax sprue, pattern tree. Okay, and this is the slurry. Then what happened in this process? You can see when it immerse in this ceramic slurry, basically the zircon based ceramic slurry was used. So what happen? This it forms certain layer. Yeah. Then this is the step 4. Then after it take out from the, let's say step 5. Then after it take out from the ceramic slurry dip, we are having this kind of assembly. I will write this dip in a ceramic slurry. Dip in a ceramic slurry. Step 5. Then this is the pattern tree. Just after take out from the ceramic slurry container. Okay. Then what happened? The coating, ceramic coating is that means the ceramic shell is formed out of this wax pattern. The thick slurry coating is generated inside this on this wax pattern. You can see this kind of ceramic coating is generated. Okay, ceramic coating is generated. Ceramic coating has generated because of this thick ceramic slurry. So then what happened? The next step, the fine sand is sprayed. Spray of fine sand. Very fine sand is sprayed. Okay, very fine sand is sprayed to this wax is proof. The spray or some situation it is hold under rain of sand. Is hold under rain of sand while rotating in a 2 axes. Okay, let's take there is spraying the very sand, fine sand is sprayed while rotating this pattern. So then what happened? The thickness also increases. Spray of fine sand, and the fine sand is sprayed. While spraying this fine sand, this robot, this sprue is rotate in a 2 axes simultaneously. Rotate in 2 axes simultaneously. For this rotation, the robot arms are used to use for this one. Okay. So then the next what happened? This thickness also increases because of this spray of the fine sand. Then also strength also increases. This shell strength also increases, and also the thickness also increases. So then what happened? Finally, we are having thickness also increases because of the this sand particles, and also the strength of the shell also increases. Then this is this mold is allowed to dry in a okay. Then step 6. Then it is allowed to dry. 6. Drying in low temperature. Normally less than 100 centigrade, they allow to dry. So then this is the wax. Okay, this is pattern. Then outer shell has formed. Outer shell has formed this ceramic layer. Then you can see ceramic layer has formed. Okay, then the fine sand layer. Then this process, then after this one has dried, then this operation is repeated. That means again this dried pattern tree dip in a ceramic slurry. Then again fine sand is sprayed onto this shell. So what happened in this repeating this process, that means again this one is moves to step 4. Again this one is step 4. Again this is dip in a ceramic slurry. Then again this fine sand is sprayed. Then again it allowed to dry. So this operation is repeated in several times. Then what happens? The thickness of the shell increases and the strength of the shell also increases. After repeating the several steps, the certain thickness and strength we can obtain for the shell. Then after the next system, after obtaining the certain thickness for the shell, this is placed inside the oven. And heating. Placed in a oven and heated. The two different things happen in this process. One is the wax is molten out. Wax is molten out. The wax is molten out. Then the ceramic is hardened. Then the temperature also actually the two steps, to take out the wax molten out, the certain temperature is maintained. After the greater temperature increases, ceramic is hardened. That is increases to beyond the 1000 centigrade. What happens? The ceramic get hardened. So then finally this I use the same diagram for this one also, because that is easy for me. There is a place inside the oven. Then while heating, what happens? This wax inside this wax molten out. Okay, this wax is collecting. This wax can also recycle. Okay, so then what we are remaining after molten out this wax, we are remaining this kind of shell. Ceramic shell, the hollow one. Okay, this kind of one. Then with a certain thickness, because of the sand and also the ceramic coatings, then certain thickness. Okay, then and also the fine sand also there. Fine sand layers also there. So you can see this is the hollow, this kind of pattern. Sorry, the mold we are having. We have already having the mold. you can see this is temperature further increases so that the ceramic get hardened. You know, when increase the temperature, ceramic get hardened, the temperature increases again further. Then what happen? This shell get hardened. Shell get hardened. Okay, shell get hardened. So then step 8. Step 8, the pouring of molten metal. So now this mold is ready to pouring after take out from the step 8. Molten metal pouring. After take out from the oven, that is writer like this. Placed in a vertical manner. Placed in a vertical manner. Mostly it is mounted on a sand chamber. So then this is the mold. This is the mold. The mold is ready to pour the molten metal. Okay, it has a certain thickness and also it's hardened using the place in the oven. So then the molten metal can pour to this molten metal pouring. To this mold, the molten metal can pour. Then the molten metal fills with this moves to this product cavities. Then it fills. Then this while solidification, this sprue acts as the risers. Sprue acts as the riser. The risers, you know, you can see there's no riser for this part. This manufacturing process. This riser, sprue acts as the risers. You know the purpose of the riser to avoid the shrinkage cavity defect. That this sprue keep molten metal until the part completely solidify. Then lack of volume due to shrinkage feed from the sprue. Okay, feed from the sprue. So then the molten metal pouring. Then the step 9. Step 9. Mold is break using the vibration method. Break using shaking and vibration. So then what happens? This outer shell breaks. Let's take this the part after we are obtaining this kind of thing. Okay. Then what happens? This outer shell, because of the vibration, this ceramic very brittle material. So this brittle material removes the shell, breaks and removes from the solidified tree. Okay, assembly tree. So then the last step, step 10. The last step, parts are separated from the assembly tree. Okay, parts are separated from the assembly tree. That means parting of operation. The parting of operation use to separate these parts. That means this is the assembly tree, product assembly tree after removing outer shell. They are having this kind of product. This you can see that this parts are assembled to this sprue. Okay, this is the part we want. So then the parting of operation, that means cutting of operations are used to separate these parts. So then as the finished product, they are having this kind of products, separated parts. Okay, several parts we are in. You can see this. This is the process of investment casting process. It having the this kind of 10 steps. 10 steps starting from the. I will explain that steps again. Okay. This is the first step. This is the product we want to manufacture. Then this is the design wax pattern by giving the shrinkage allowances and everything. So then first step, manufacturing of mold to make the patterns. This is the wax pattern. To make this pattern, we want the mold. This is the mold. Okay, this is make using the machinable metal like the metals. So then CNC machine operators are used to create these cavity areas and the mold. So then this is the mold to make the step 2, wax injection molding. Wax injection molding process is used to make the wax patterns. Okay, then this is the wax patterns. Then these wax patterns are assembled in a wax sprue like this by using this assemble using the flame. That means these two areas are heated using the pencil torch flame. Then this is when it touches the wax sprue, then it is hardened. When it hardened, it attached to this wax sprue. That is how this assembled. Then this is the wax complete pattern for this operation. Then next step, that this wax pattern tree dip in a ceramic slurry. Okay, then when it take out from the ceramic slurry, the coating is generated outer of the wax pattern. So then after take out from the wax ceramic slurry container, then the fine sand is sprayed onto the surface of the pattern. So then whatever the thickness increases and also the strength also increases of the shell. So then this process is repeated to get the certain thickness for the shell. Then after getting the certain thickness, that is placed in an oven. Then it is heated. While heating, whatever the wax molten, then the molten out from the tree. Then we are having only the shell. Then this shell is further heated. Then whatever when heating the ceramic, it get hardened. The hardness increases. Then after removing the oven, this is righted. Like this. Now place in a actually the sand containers are used to place this oven in vertical position. Sand containers, sand based containers are used the vertical. Then this mold is ready to pour in the mortar metal. Then the mortar metal pouring. You can see this in this pouring the very high temperature, higher pouring temperatures are used. Then this sprue acts as a riser for this solidification. Then after it's part solidify, the shakeout process is used to remove the shell. The shell is break using the vibration process. Then shell part can remove. Then after removing this shell, the part can separate from the sprue using the machining operations to remove this part. This is the part we manufactured in this investment casting process. Then this is you can see it having this several steps. It also needed very high technical based knowledge, and also the very high tech equipment also needed. Some situations the robot arm is used to rotate this pattern in a 3-dimensional axis. That means after take out from the ceramic slurry, the robot arm is used to using the robot arm, this pattern tree is rotated in a 2-dimensional 2 axes simultaneously to get the uniform thickness layer around the wax pattern. So then the very high technology is needed for this operation, so that this operation is only suitable for specific products, and also in a mass production this is only suitable for mass production, and also this is limited to smaller products. Okay, if we take the very high large size of product cannot manufacture in this process because it's the practical limitations of the process. Think about how the large products are manufactured. It's a difficult process. Okay, only this process is suitable for few kilogram of products. Okay, smaller products. Okay, relatively smaller products can manufacture using this investment casting process, and also the surface finish is excellent. Dimensional accuracy also very high. So this manufacturing method is suitable for mass production only. Okay. Then next last manufacturing process we are going to discuss is not last. Next manufacturing process we are going to discuss is the centrifugal casting. Centrifugal casting. Okay, centrifugal casting. In a sand casting, gravity pressure is used to flow the mortar metal into the cavity. In a die casting, externally applied pressure force is used to flow the mortar metal inside the cavity. In here, centrifugal force is used to flow the mortar metal inside the cavity. That's why it is called the centrifugal casting process. Okay, centrifugal force of mortar metal is used to flow the mortar metal inside the cavity. Okay. Then in this process only limited shape of product can manufacture in this process. Product like cylindrical cylinders, larger diameter cylinders, and also larger diameter rings, flywheels, pulleys are manufactured using this centrifugal casting process. Then normally it is done on a permanent mold. It having the three different type of casting methods called true centrifugal, semi centrifugal, and centrifuging. Okay, casting, centrifugal casting. Okay, so then what happened, I will explain using this process, using this one of the method, true centrifugal casting process. True centrifugal casting process I am going to explain. So then in a true centrifugal casting, this kind of a cylindrical mold is used. The steel housing. Okay, the cover plates, steel cover plates. Steel cover plates, and also there's a refractory layer. Inside there's a refractory layer. Refractory layer. This is the cylinder. This cylinder is mounted on the rollers. Cylinder is mounted on the rollers like this. Cylinder is mounted on the rollers. Okay. If you look from this direction, this structure is like this. If you look from the end elevation, it's like this. The hole. Then this is mounted on the rotating rollers, drive rollers. Okay, this is rotating in this direction. This one. The inner left side there's also another roller. Then while rotating in this one rotate in this direction. This one also rotate in this direction with the same speed. Okay. Then what happen? This is rotate with a we can rotate this one. This mold can rotate in a certain velocity. So then what happen? In this centrifugal casting process, what happen? While rotating the mold, mortar metal pours to this internal. Mortar metal pours to this internal. Okay, mortar metal pours to this internal. So then what happened? Due to the centrifugal force of the mortar metal, this moves around the mold and it forms uniform thickness layer because of the centrifugal force. Because of centrifugal force, this mortar metal tends to away from the rotating axis. This is the rotating axis. Tends to move from the rotating axis. So then it forms the uniform thickness layer around this on this refractory layer. So then what happens? Then allowed to solidify while rotating. It allowed to solidify while rotating. Okay, it allowed to solidify while rotating. After finishing this pouring, it allowed to solidify while pouring. So then what happened? And actually this centrifugal force, another important thing is happen. The air bubble backward then escape at the center. Okay, air bubble backward and escape from the center. Then because of the pressure acting on this mortar metal, because of the centrifugal force. So while rotating, this mold is allowed to solidify. After it solidifies, we are having the product cylindrical shape. This cylindrical shape we can take easily by removing this cover plate. We can remove from this one end. This finally we are having this kind of product. You can see the larger diameter. This kind of cylinders we can manufacture. Larger diameter cylinders are manufactured using this method called centrifugal casting process. Centrifugal casting process. Okay. Semi-centrifugal casting process, what happen? It's a vertical mechanism. I'll just explain that one. It's a vertical mold. Then mortar metal pours to mortar metal. That means it having this kind of cavity area. It rotates in a vertical plane. This is the one we want to manufacture. Okay. The mortar metal pours to the center in a semi-centrifugal process. So then this is spread in a radial. This mortar metal move radially outward from the center of rotation. Then in this process, this kind of ring shapes, the objects are manufactured. The pulleys, flywheels like objects are manufactured using this method. Okay, this kind of ring shape and cylindrical shape. In a centrifugal casting process, what happens? In centrifugal casting, the centrifugal force used to flow the, that means it also having this kind of thing. Mortar metal pours to in a center. Let's take, this is the one. The mortar metal pours to this chamber. Then this is small nozzles are there. Then the cavities are placed in at the circumference of the rotating disc. This is the cavities, product cavities placed around the circumference of the. So then what happens? The mortar metal the forced flow and with the pressure to this cavity. This is called centrifuging casting process. Okay. Keep remember this true centrifugal casting process, how it how it used to manufacture this kind of cylindrical shape products. Okay, I think you all more clear this centrifugal casting process. Okay, the next casting operation we are going to discuss, the last casting operation we are going to discuss is the continuous casting process. Continuous casting process. Continuous casting process. The process is continuous. Process is continuous. That's why the it's a continuous casting process. In this process, this kind of slab uniform cross section products are manufactured. In this process, uniform cross section products, slabs, blooms, billets, this kind of uniform cross section products are manufactured using the continuous casting process in a continuous manner. Okay, most of the cases continuous casting plant is attached to the rolling mill. When the rolling mill is attached to the continuous casting plant, it can manufacture the different type of product like channel sections, C channel, I channel. Starting from the blooms, it can manufacture C channel, I channel. That means starting from the blooms, it can manufacture I channels, channel sections. Is a structural component of buildings, C channels, railroad rails. Okay, can manufacture using this. Starting from this blooms, starting from the slabs, the sheet metal can manufacture. Starting from the slabs. Okay, sheet metal. Okay, sheet metal can manufacture starting from the slab. So then from the starting from the billet, rod shafting, and the cables. Okay, rod shafting, cables can manufacture starting from the billets. When this continuous casting plant is attached to the rolling mill. Let me explain this continuous casting setup. First, it also called open die casting. Why is called open die casting? The mold is open in two sides. That's why it's called open die casting. Mold is open in top to pour the mortar metal. The mold is open in bottom to take out the solidified part. Okay, open die casting. Let me explain this setup for the continuous casting. Okay, the continuous casting process, it having open mold. Let's take this the steel mold, also steel mold. Okay, inside there's a water cool channels. The water cool channels are passing closer to this surface. The water cool channels inside there. Okay, then the mortar metal pour to this mold from the tun dish. This is the container. This container is called tundish. Intermediate container for the motor metal. Intermediate container for the motor metal. Intermediate container for the motor metal. This is called a tundish. This is a motor metal. Motor metal. To this tundish, the motor metal pours from the electric arc furnace. Okay. To the tundish, the motor metal pours from the electric arc furnace to the tundish. I think you already know what is meant by the electric arc furnace and everything. We discussed. We already discussed. Okay. This is the motor metal in a electric arc furnace. Then this is motor metal pouring to this. This chamber. So then, while passing through this mold, it gets solidified. It gets solidified. Then it forms this kind of solidification pattern. Initially this surface is solidified. This is how it's solidified. Then this is still motor metal. Still motor metal. Only surface closer to the mold wall gets solidified. Only this area gets solidified. So then solidified part is taken in this kind of manner. Then this one is passes through the set of rollers to get the required output shape. This part is heavy rollers are there. Set of rollers. Okay. Set of rollers rotating in this direction. Each roller have to synchronize with the speeds. So then what happens, this area is solidified. So then solidified part can take out. So then it is passes through the set of rollers. They also rollers to manufacture product as the slabs, the blooms and the billets. Okay, these are the output product. It's a continuous manner. It can manufacture in a continuous manner. If slabs are manufacturing, this plant is set up for slab manufacturing. These rollers have to adjust. This distance have to adjust. That means this distance have to adjust to manufacture this slab. Okay. Once it manufactures slabs, it can manufacture. Once it's set up to manufacture the slab, it can manufacture only slabs. Once it's set up to manufacture the blooms, it can manufacture only blooms. When it's set up for the manufacture billet, it can manufacture only the billets. Okay. The part is continuously out from the mold. This is the mold. Okay. Then you can see why it's called the open die casting. In a one end it is open to pour the motor metal. Then other end it is open to take out the part. It's a continuous process. There's water cool channels are there. Cooling water to accelerate the solidification process. Water cool surround then this water can taken from this kind of manner. Taken. Then there are also the very high argon. Then argon gas is blows to the top of the motor metal pool. Argon gas blows to this top of the molten metal pool to avoid the contact with the atmospheric oxygen. Otherwise, it may get oxidized. So that because of the oxidation, the impurities may add to this product. So that to avoid that one, the argon gas is blows continuously top of this molten metal pool. Okay. And to make the molten metal pool to a certain level height, the X-ray detectors are used. X-ray sensor detectors are used. Two X-ray detectors, X-ray level detectors, X-ray level detectors are used to measure this height of the molten metal pool. According to this signal given, the Trundish inclination theta is varying automatically. Okay. So what happens if the level goes down? This inclination increases, the more metal added to the molten metal pool. Then again the level increases. If level increases, this inclination decreases. So then it reduces the molten metal flow into the molten metal pool. Then level goes down. Then to make the level to a certain height, this Trundish is automatically the control. Okay, that is detected by the X-ray detectors. Okay. This is the setup of the continuous casting plant. This is the setup of the continuous casting plant. Then here we discuss all the casting processes. For the casting processes, we discuss six casting processes we discuss. Okay, here we discuss other casting processes we need to discuss. Then on next day class we are going to discuss the basic calculation related to this metal casting process. Okay, now let's continue next day class. Thank you.